Hi. Hi. Today is first talk, Vibek's talk in this stage. Online talk on today, and I introduce him. Maybe he will introduce by himself, but firstly, I will introduce. He is assistant professor, Institute of Micromechanics and Photonics, Factory of Mechatronics, Warsaw University of Technology, Poland. And he will visit here from the last Wednesday to the April 1st to do some works. And today he will introduce the past project and the past experience and ongoing project, and then what is the purpose of this thing he will introduce. I have already introduced this is two site, like, ちょっと待ってね。共有 change here like this. Yes. One of them is the Warsaw University of Technology's personal profile site is here. And also he is the visiting researcher of Waseda Institute for Advanced Study, WIAS. So therefore, this is also the showing about his background. But I ask maybe he will introduce by himself more in detail. So therefore, can I start your talk, Vivek?
Yes, Professor.
Yes. Let's start your talking, and I will finish your introduction. Yes, let's start. Thank you.
Okay, thank you very much, everyone. And thank you, Professor Matsumaru, giving me the opportunity to offer my talk. And today is just the basic introductions. Of course, this introduction also includes the research which I have be part of it as a part of cross-border collaboration with Professor Matsumaru laboratory and my laboratory back in Warsaw University of Technology. This work today, I will be giving a brief discussion of this work, which we have been doing for since last 1.5 years. To be precise, since my last visit, what was my last visit, how we continue this collaboration through a scientific research and different academic activities, not only limited to research. So I will introduce myself, like as Professor Matsumaru already gave a brief introduction, but I will give you here the idea what is my what I am. So I think the first two you are already aware of it, that I am I'm already employed in Warsaw University of Technology, but I will give you what is my research interest. So this is, as you can see, this is my laboratory with the available robots, but we recently also have other robots, which is like a Boston Dynamics robotic dogs, and also we have Vision Lab which has multiple camera to observe or record human movements, because since my work is mainly focused on understanding the human movement dynamics or kinematic configuration during any kind of movements. Currently my collaborators, as you know, Professor Matsumaru, who has been my first collaborator after I graduated from PhD and postdoctoral research, and then recently I had one more collaboration from IIT Madras from India. But you may ask, what is my purpose of visit this time? So this time I have been visiting as a visiting scholar, which has been funded by Waseda Institute of Advanced Studies and also Professor Matsumaru for his continuous support. But today I will give you the idea of what we have done so far, the research, because the idea is that doing any kind of basically collaborative research or scientific visit must have some meaning, or at least some have outcome. So what we do is just not about just visiting and delivering seminars, but we should have the impact of those outcomes or also those visits. So I will show you the works which we have been done so far, and then what we achieved from that work and how we continue those collaborations. So I will go today's agenda. Basically, as you can see, that why we focus on human factors. That means why it was important to investigate human movements or human factors, of course, in terms of robotics, because our common research interest is in robotics. Then we will talk about the last time when I came here, why we recorded data, why it was essential, because of course, publicly available, many data set is available, but why we still focus on collecting more data. Then we will discuss about that, what kind of neural networks we selected to analyze those data for some purpose, like, to understanding or to analyze the human movement or the postures. And we will show some of the result, that what we achieved during this 1.5 year of our research collaboration cross-border. And at the end, we will go with the scientific achievements. That means what we achieved. It is not only limited to publications, but there is a different other platform that what we achieved and we collaborated. So this is, as you can see, this part of work was during my doctoral studies, that why I start studying human factors. It did not start recently, but it started back in like 8 years before, when there was only first generation of Kinect camera was available, right? Because we know the human factor. When you talk about human factor, that means we are talking about the subject human, and we can analyze the human in a different categories through the movements, which is useful for biomechanics, to understand for the medical purpose, for rehabilitation process. There we mostly focus on lower limb of the body. That means the movement of walking. That means how the gait analysis we are approaching, or we are purpose of the gait analysis to understanding the walking movements. That means to give them rehabilitation exercise so that they can improve. There are many other processes that where human factor is important. So if you look about the first initial stage of human factor or human research, understanding the human movement was for surveillance purpose, was for understanding their human improvement, or how to say that, human analysis, the movement analysis in the industrial factor, so that we can, in the surveillance, we can understand what the person is doing in case of any anomaly activities which can be dangerous, potential dangerous for other people, and the person itself, because if the person is aging or aged old person, so we need to understand in the industrial setting, it's a very critical to understand the human movements, because when you are interacting with a industrial machines or robotic platforms, it is very critical to understand that we don't do any mistakes, okay, that can cause a potential dangers to the human being, because they are the part of this industrial revolution, not only the machines, but also human involvement, because it's a collaborative work like this. And also nowadays, when the technology evolve, when I'm saying technology evolve, people are more dependent on smart technology, not only just smartphones, but also smart machines. Like, so in humans, or basically in home environment, we are more enthusiastic or more into the smart technology that will help us to make our life more efficient and comfortable. Because in certain scenarios, some people who are aged or some people who are disabled, they need support, because it is difficult, or it is also financially very expensive to hire other persons to in the long-term goal. That's why machine is very helpful when you talk about long-term goal. Maybe short-term is human can be helpful, but for long-term, machine is always, because of its consistency and repeating process, which human may not do for a long time, because we do have our limitations. Like machine do have limitation, human do have limitations. So this here I talk about why we study human factors, right? So what was the research motivation, which I already discussed about, that we research motivation is to, because since our research was concept by the autonomous robots, that means which like a kind of autonomous service robot to help or to support the human, then for this purpose, we have to first of all understand the human. If you want to support the human, you need to understand human. Now you can understand human in a different context. Human kinematic configuration, the movement, you can understand with the different gesture or facial recognitions or psychological cognitive characteristic. But here we focus on the movement dynamics, that the biomechanics movement dynamics. Of course, biomechanics movement dynamics can be different purpose. Somebody do it for rehabilitation in the lower body part, somebody do the whole body. So here we are talking about full body human motion analysis. That means how we can analyze this through understanding its kinematic configurations. For that purpose, people use initially, like decade ago, people are using different kind of sensors, right? And those sensors can be useful because they might be, they have less error, but also those are very cost effective because they are not, I wouldn't say cost effective, but they are very highly cost. And also in many scenarios, human doesn't like to have some kind of sensors or some kind of machines in their body. So that's why in the last decade, people are more focused on wireless imaging systems, like or wireless sensor, where you don't involve any sensor with the human body. So that's why this Kinect system or Kinect imaging system, or in the other terms, we say that Kinect RGBD sensors, like, that sensor has been developed with the time. Like initially it came with first generation Kinect, then we moved to the second generation. Now we have Kinect, the third generation, which is Kinect Azure. So in this work, we want to discuss why only the part of human postures, not in other human factor, whether facial recognition, gesture, or like cognitive engineering, because we want to focus on service robots, autonomous, and service robots sometimes can be considered as a humanoid robots. And when you talk about humanoid robots, which must also follow the kinematic configurations or the structure or the postures of the human, and then mimic or imitate or regeneration of that posture according to the humanoid robots, because robot has their own kinematics and dynamics, so they will do. But for that, they need to understand the human kinematics configuration or human postures. So now we were talking why collecting human data is still essential. As I said, the very nice word which I wrote here, the more the mere. It is the very common word which we used in our regular life. We say that the more is more better, because we know we have data, but data is, because you remember, as I said, initially the data was recorded with first generation sensors. Then it is recorded with second generation sensors. Then it is recording with a very restricted environment. Then it recorded with a very restricted cultural diversity, right? And these are the restrictions still exist. There is a data, but there is also restrictions that we need to, that's why with time, we need to also improve the quality of data. Also, we have to enlarge the data with more diversity and with new generation sensors. So that's why we said that in the second point, as I said, that first and generation imaging system. And also another point is that which we want to investigate during this collaborative research is that if you look at the majority of public data set, I'm not saying all data set, but majority of the public data set, they were recorded with not only with first and second generation of Kinect or RGBD sensor, but they also always in a restricted environment, in a frontal view, or the environment which has multi-camera. When I say multi-camera, that means it's covered 360 degrees. So in the both case, what we are missing is that in some scenario, we are not able to understand the kinematic configuration of the human body. For example, if we sit from the standing, or if you do some kind of movement of the exercise that is not visible proper way. Of course, in the multi-view camera, it is visible because you have every camera, but multi-view is also expensive because you have to set up multiple cameras. You have to also do the calibration approach to make sure, and also multi-view camera give you more features because more data. But what if, when you are talking about the system where you're gonna apply into real time. How you gonna do that? Because there you cannot expect the whole environment should be multi-camera, like a 360-degree camera. Robot can be placed, or any kind of machine can be placed anywhere, whether it's front view or there is side view. So we must have the intelligent system that not only support the frontal view, that means the front view features, but also have the capabilities to support also side view. This is important. That's why I said that incorporating side view of the body is less common, which is because why it is less common? Because it is mostly used for rehabilitation process. So when you talk about the gait analysis and the lower part, so it is very restricted into environment, but it was not that analysis for the full body motions, that means full body activities or full body postures for robotic applications. Please praise the concept for the robotic applications. And what is the problem? As you can see here, in the front view, you can see the skeleton is very easily, but when it is side view or something like this situation is always much error. So this is the problem, where the idea is how we can solve this problem, and what kind of the solutions. So we found there is two kind of solutions that we can do. Is that we have to use new generation depth sensors, because old generation depth sensor has limitations, because you know that all the depth sensors comes with their inbuilt pose estimation software. Also, we have developed many pose estimation software by many researchers, and we can use it. But then what will happen? You are making the algorithm more time effective, like not time effective, but more time consuming, because you will collect data, you process data, and then. But what if we come with the new generation depth sensor? They are using most newly developed neural networks algorithm to directly pose estimation. So it's self-inbuilt. So this is useful to analyze. And also we are strategically placed the camera system in the side view so that we can do that kind of activity, that we can understand the kinematics of the body. That means the kinematic, again, I'm saying kinematic configuration, which means the movement mechanics from the side view, how much that between two joints, how the angle is changing or how it is moving. So this is useful. And for that purpose, also one thing we like to say that one thing is missing also, which we discovered during our data set, that if you see all the public available data set, they are restricted to one environment. They might have multiple different subjects with the cultural diversity, but they are restricted to, like, if you see most of the data set are built by the Western countries, and they do activities according to the Western cultures, like, you know, some activities. But what if, and they call it as a benchmark data set, right? So, and people are using the same data set to develop new model and apply to the, for example, real-time system. But an activity done in a Western culture may not work in Asian culture. For example, we are in Japan. In Japan, we have a different way of greetings people than in Western culture, where we do the handshake. So the robotic application or a smart system, even though we developed a very advanced neural network, which is based on the data set, which is done or recorded in the Western culture, may fail in a Japanese culture, because the robot may not have the knowledge. Ultimately, neural network is, when you train, it collects the knowledge. And based on this knowledge, then they pattern recognize or they analyze and they say. But in this case, robot will not have the knowledge of doing the activities. So what we need is here, we need to add the cultural diversity into the activities or actions. That's why you see that we try to push ourselves. And the part of this research collaboration, which is for last 1.5 years, and I spent time in 2 months in Professor Matsumaru lab, the idea was to record data or kind of same activity in a Western culture and in the Asian culture, like, you know, two different lab environment, and we want to see how two different society do the same activities and the kind of. Also, second thing which I mentioned earlier, that imaging systems, like we want to use new and advanced imaging system. Of course, subject is there, and recording environment, which I mentioned, as you can see in the figure, we want to focus on very side view, like, as you can see here, the example, if you see that, like how we set up the camera. This is pure sagittal view, and this is our 50-degree angle view. And the good thing is that we have collected huge amount of data, that is almost 120,000 of samples. So this is still, we believe, small, because we have activity categories is 20, and we want to extend these categories up to 50, but including the cultural diversity, not only limited to only Europe, or not only limited to Asia, right? So this is, I will not go. So these are the example how we collected the data. This data was collected in Professor Matsumaru lab, and this was collected in our lab. And we all focus on, as you can see, this part, that how people sit, what is the angle, rotation, and how my hands is gone, and look at this hand. So these are the things was very important to understand, which you may not understand from the front view, that how people were sitting. Okay, sorry. So I'm sorry, just a second. Okay. And but still, as you know, that the problem is with us, that as you know, that even if you are using very high advanced computing system or imaging system, we always have some error. It is not only limited to camera. In anything, it is very hard to disclose a system without error, like there is zero error. It's always there. So the most important thing is how we solve those error in efficient way. Like it doesn't take like a basically long time and very complex method. So the thing is, like, we could directly apply a filter algorithm, and we could try to solve. What we try to do is that instead of applying very complex filter, why not we do some missing joint filling approach, which is very simple, which is the strategies that they are using either few frames before or either few frames after, based on which frame has the better visibility of the body. And we keep those joints at the same where it is not visible, so that we do not lose information, because information is very critical in neural network. Because if your neural network will not have enough information, it will give you false positive data results. And then what happened, because of this first process, we then use the clear the spike noise is a very simple method, which doesn't take very complex processing, right? So these two together is even the less process and less time consuming than when you use some very complex filtering method, because they go to very detailed. So we try to do this. Of course, next is, nowadays everybody wants to use machine learning, deep learning, neural networks. So we try to also use. My previous doctoral study, I used very classical method, like probabilistic method, where we did not think about neural network. But nowadays, since we have the resources to use neural networks, so we use different kind of neural networks, okay? So right now, for last 1.5 years, we try to work in two categories. One was we used initially, which we published last year in Roman paper, that is a supervised method. Like we use some probabilistic neural network, which need human annotations. That means human expect annotation, which is very subjective, but it was useful. We want to start with something, right? But at the same time, we want to do that. We want to select a resourceful or scalable neural network that is very easily integrate to the real-time applications, or like a very time efficient. So for that purpose, we use a probabilistic neural network. Because why? Because it doesn't have multiple hidden layers. When you talk about multiple hidden layers, that means when you are using very complex neural network, that might give you very, very good result. But also don't forget that that might cost you very memory and very time consuming, and you have to do trial and error with the different parameters. So we try to use a simple probabilistic neural network which doesn't have multiple hidden layers. You have input layer, and then you have pattern layer, and you have summation layer. There is nothing. Now this pattern layer and summation layer is doing what? The pattern layer is doing using some methods, which is like a kind of distance and distribution function, and try to match the input sample with the training sample. That means how much similarity is there, and then you sum those samples into, because when you collect the similarity, we group them, like, that this sample is similar to this group, so we group them, and then we collect, the summation layer is collect all the group, because first sample can be group 1, second sample can be also group 1, then we summation, so that we can know that this, from this frame to this frame, has belongs to class 1, this frame to this frame belongs to class 1, and this is how we calculate the output layer. Also, we do have then what, when we publish this paper, we came out, also we have to think that we cannot always consider supervised learning, because supervised learning is always subjective, because the annotation is needed by the human expert. Now, human expert can be, I have a different view of understanding, you might have a different view of understanding, but how we came to conclusions that we both will have a different view, or our subjective approach towards watching some activity will be similar, because we have a different state of mind, different knowledge. So we want to come up with a solution where we work with no human annotation. When I'm talking about no human annotation, that means we are using again, we focus on a very scalable neural network. That means no much hidden layer, but a simple methods that can work without the help of labels. That means we give the data, the neural network or the model have the knowledge itself, that it can categorize or it can group those postures into some category. Now it can be done in a different, we use some kind of self-organization map. That's why the name itself, self. That means it says that I will do by myself in my own knowledge. And the knowledge can be also in a different strategy. You can use some different distance function, that's up, then you can use some kind of what is called checking the nodes of the weight, how you calculate. There is many other approach, and this approach we are still we are right now working, and we will be also in the preparation of submitting a paper, and we'll see that how it looks. So this is our idea, but I will not go, because in my final presentation, so when I will be here, I will discuss more details. So I will be more discuss about the work which we publish. So as I already told, like, you know, that when you talk about this neural network, that initially, basically why we said improved, that how we improve this idea. So initially this neural network used to use Euclidean distance and Gaussian distributions, right? This is the neural network. The main structure of the neural network was initially this. But we came with the conclusions that since we are observing the side view, the angle is very important, because how it's changing the angle. Frontal view, you might not see that, you might not have the features of the angle that evident, but in the side view it is. That's why we came with a conclusion that angular distance will be very appropriate in this scenario, because our view or our recorded data was in the side view, which is often called a sagittal or profile view. Then we try to use different distributions. And once we use the different distribution and different optimizer method, that means we use also Gray Wolf optimizer, and that also two strategy, we came out with a conclusion this. As you can see, the result with the angular Laplacian, we achieved the best result, 95% accuracy compared to other method. We use some different method. And as you can see that angular Laplacian is quite similar with the ground truth. Okay, this is this is the video, but here you can see this angular Laplacian and with the ground truth is very much similar. We do have error here, as you can see, but also we cannot expect that a model can work up to 100% efficiency, because it means the model is giving you false positive. But also important was our method was to look for the time efficiency. That means if we are making the model, how much is time efficiency for real-time application in future. We can see that here it little compared to other method, like here it is poor like this, but here we can see that it is better time efficiency when you are using like different method. But of course there is a one state of the math method which has better time efficiency, But overall, if you look at those things, overall, we still have in the Euclidean Laplacian, angular Laplacian has better time efficiency. If I forget about this XB net, because it is very important. Also, we should focus on those time efficiency, because model, you don't just make the model just to get the accuracy, because you also have to check what is the time efficiency of your model, because why you want to develop a work if the work does not offer you or facilitate you a real-time applications. Of course, there are many research that you do to focus on developing a model with accuracy, but also we need to focus on also, if you want to looking for that in future, you will apply this work into in the real-time applications. So this is the first part of the work, which is the, here I will give you the overall diagram. Like if you see that how we record the data with the different, then we detect the skeletons, as you can see. So this is so far what I said is all. And then we fill the missing joints where there was a missing. Then once we're done, you see that there will be some joints who are missing, but it is now corrected. And then we do some kind of filtering method, because even after missing joints can be shaking because of the different occlusions. So we try to improve. And then we use this applied neural network and we just check, because since it's a probability network, we are checking here probability. The outcome of the neural network is probability, that what is the probability of this kind of actions. The probability can be more, probability can be less sometimes, right? So this is why it's a probability network. So this activity is a Japanese way of gratings, as you can see, like this. And just we want to check what are the things. Okay, so and another work which we are doing, I'm not going to give, this is like basically which we just started, like, you know, we, as you can see, we did everything similar. Only the thing is that where we use two different methods. Here you use the totally unsupervised method, that means where you do not require any labeling. But recently we discovered that since we have a huge amount of data, and what we can do is we can reduce its dimensionality so that we can make this model much more faster. Like, you know, of course, it may or may not, but we want to reduce the dimensionality so that we can work better with the model. Sometimes model has the effect of the model is based on the data also. So this work is basically, so this is, I will not go this part. This work is basically here, we are basically, as you can see, is automatically finding its postures, different kind of postures. Okay, based on this model, which was not trained on any label. That means the model was not given any knowledge of what kind of activity it was. Previous work, which I talk about, probabilistic neural network, there we give the knowledge during training. That means these postures or this frame is belong to this posture. When you talk about postures, means this class, this frame. Here we don't facilitate to the neural network that this frame is belong to this posture. We just said that this is the frame, and now you evaluate. Of course, it can evaluate in a different way of calculations. Again, distance calculation, different approach. So now you may ask why you did this research and what did you gain from this, your last time visit, your last time coming here. What do you just show your work, but what you achieved. So here is the achievement for our work. We published together as a cross-border publication 3 journals. In the sensors, we published 2 works. In IEEE Access, we published 1 work. And these are the work from the master students. So if I see that one here students is there. So if you do good work, it will be always appreciated by the scientific community, not only your lab or your supervisor, but your, as you can see here, the proof of this. That's why these are the master students' work that has been published in a very good journal and very respected journal, like as IEEE Access and this. Similarly, we also publish as our collaborative research into Roman, which is one of the also considered as one of the prestigious conference, and also Robi. And also we under one paper is under review and one paper is preparation, which we'll submit. So as you can see. And also not only we limited to, remember, not only we limited to publications, we also try to find out different avenue to these collaborations. What is the different avenue? Here is the avenue where Professor Matsumaru and my current boss in Warsaw University of Technology, they both together open an issue, special issue in the Sensor Journal that offer other young researchers to publish their work. So as you can see, collaboration is not about doing research or publish paper, but also collaboration make it in a different avenue that we still keep. Okay, so these are the avenues that where we still has the opportunity to keep basically this collaboration alive, or that means the continue, right? Then this is another opportunity. So last year I had a very privilege to part of a project which was funded by Polish National Agency, which is from Polish government, where we developed a project where where the expert from Waseda University and from Warsaw University of Technology offer the expert knowledge or offer the suggestion to the doctoral student that how to write a research proposal to receive the external grants. When I say that receive the external funding, it can be from Japanese government, which is JSPS. There are many other. So to give this project was very limited to the doctoral students, and give them idea, because when you reach to the doctoral studies, at some moment of time you have to be independent. When you say independent, you have to know how to write research proposal so that you can receive some funding and create your own laboratory. So these are the things, as you can see, the point by point. So from Waseda University, I have the opportunity to get expert in my team, because it was a work between me and Professor Matsumaru as a team for this. And from Waseda University, Professor Matsumaru, Professor Wu, and Professor Kamata was participating and was offering expert knowledge. And also from Warsaw University of Technology, Professor Teresa and Professor Sitnik also was giving expert knowledge from the student from Warsaw University of Technology. And finally, it was concluded into Warsaw University of Technology when Professor Matsumaru and his PhD student visited us as a visiting professor, where he delivered not only research seminar, but also a lectures in the summer school, and also concluded the final this project, where every doctoral student from both institute delivered their final presentations about their work, and they received expert comments, expert knowledge. And also Professor Wu and Professor Kamata was also in the final meeting in virtual mode, and Professor Matsumaru and his doctoral student was present in physical presence, right? They were deliver and giving expert knowledge. And also it was a very honorable opportunity to host Professor Matsumaru and his doctoral student in our university, and they was staying there for 1 week to understand the culture, and also had the opportunity to research activities to check alike. So this is what I excite, as I mentioned. It's not about only doing research. It's, of course, it's a very important and very significant when you are coming or visiting somewhere. Our primary focus should be on towards research oriented, but also we need to find out in a different avenue and different approach that how we can continue this research. Okay, so this is what I learned. That means this is the introductory talk where I try to give you the idea that how we continue this collaboration for almost more than 1.5 years, and in what avenues and what platform, not only just research. So that is my talk. Thank you very much.
Thank you. Thank you so much. The great explanation about what you are thinking and what you have settled the approach and what this collaborative work is meaning and the future aspect. Yes, thank you. The next is Q&A. So Ji-kun, can you express your opinion hearing this talk? Firstly.
I don't have too much opinion, but I think I will read the two papers that show in this presentation later.
Sorry, what is your interest in your talk? In this talk?
In fact, I am interested in this two paper which shows in this presentation, so I think I will read it later.
Paper,
And
which paper?
the probabilistic neural network.
Probabilistic neural network, a probabilistic approach based on the combination of distance metrics and distribution function. Yes, yes. The four cases are compared. And to make the probabilistic neural network, the which component should be used for this probabilistic neural network is explored in this paper. なんか、Vivek, can you explain more exactly?
Yeah, so
explanation?
what's the advantage of this probabilistic neural network is that you don't have to focus on creating very deep network. The probabilistic neural network is rather like a kind of very simple network where you just have a basic layers. Like basic layers means that you don't have hidden layers. You have just one pattern layers and one summation layer between input and output layer. What is the purpose of pattern layer and summation layer is to just do pattern matching. That's why it's called pattern layers, right? It's matching the pattern, and based on some distance calculations or probabilistic distributions, right? That means how much probability that that this sample is belongs to this class. Okay, so so this is what it is useful, because as you know that neural network itself is a black box, right? So what happened is that when you use kind of deep neural network and many kind of neural network, you don't know what is going in between the network. You know the input you are giving, you know the features of the input, you know some optimization functions, and you know what is the expected output, because you are facilitating during the network design how many output you are expecting. Okay, so here but in between how it works you don't know, but here you are well aware in this neural network. Okay, you know that how, in what approach you are using to calculate those similarities. You understand what approach? And then you can change. That's why we were able to change those different combination of distance, as you can see, that different combination of distance metric and distribution function, because it allow us that what is the calculation process inside this neural network is being done and how it's being done. That was the, of course, then you change. Of course, this is also based on trial and error. We try with a different distribution function, and we found that this two combination is the best, or this four combination is the best. This is the advantage of this thing, that sometimes we don't have to explore or investigate very complex thing, but rather we focus on something simple but efficient. But you have to think what we can contribute to the simple thing to make it more efficient. Okay, simple things sometimes make it easy, right? But and it will be easy to understand, and you know where to contribute and where to you can explore. Complex thing, it will be first of all very difficult for you to understand what is going on behind this network. So you will be not well aware where you can contribute, right? Because if you don't know the whole structure, where you gonna contribute? This is the thing. Simple thing, it is always useful. That's all I can say.
Okay, good. It means maybe we are using for deep learning neural network, and if we think about the look for the accuracy, maybe the deep complex network should be used. But we are looking for the other direction. Real time processing is more important, we think. So therefore, the neural network should be simple. But the simple network, but we introduce the distance calculation and also the distance calculation means the category distance calculation and also the distribution. Which kind of distribution should be estimated? It's these two techniques is mixed to the simpler the network we are preferred to the priority on the real timeness. So that is the meaning of the network design. Mazi-kun, can you understand what is your further question or opinions?
Yes. Thank you for your explanation. It uses a simple neural network to get better performance of something. Yes.
Professor, your microphone.
Sorry, I haven't have to switch on. So what I've said is that maybe the Zikun's interest is the large scale language model, and to treat the large scale language model, maybe some outputting something need some time, some period, some seconds, some period. Presently, it will be acceptable, but it is also the more lighter network design or the real timeness the preferable is also the another direction maybe. Presently the large language model is the direction of large language model research work is accuracy, maybe accuracy. So the real timeness or calculations complexity is not so much considered because they are acceptable some the calculation time. But of course, in near future, the more real timeness should be preferable. So therefore, the lightweight network design is also to be applied to also the large language model maybe. Jikun's current study, which direction should you do is I don't know exactly, but maybe there are the different direction is there you can consider. It's my suggestion to opinion. Jikun, how do you think about it?
I did, in fact, from now I didn't see some connection between that's what I'm working on and this part, but I think this part is very interesting to do. So it means that I need more study about this content.
Okay, good. Thank you. なんか、Jikun, another interesting part in Vivek's talk you have found? ね、なんか、ポーランドズ・ウェイ・メソドロジーとか、ポーランド・メソドロジーとか、some cultural difference とか、and collaborative work over the country. How do you think about this?
Could you mind ask your question again. I didn't hear
Yeah.
hear clearly.
なんか you are interested in about the cross culture constellation or the cross border collaborative work or something? Are you interested in about this kind of thing?
I have interest in this things, but I don't know the what specific details about this. So
But if you have some chance, you should encounter some other people, not only the inside the laboratory, but also this kind of opportunity is Vivek has coming here from Poland. So therefore, you can learn a lot from him. And also he is come from born in India and then go to Europe and studied at there. So this kind of experience is also maybe you can learn a lot from him. Not only the natural, yes, you are also the studying in here in Japan from China, but also not only Asia, but also the Europe and go to some other Orient is also the interesting. Maybe you are interested in. Yes, sure. Also, the hissing. Can you say something about in addition or some other aspect you can discuss?
I think I almost know all the details about those things, so I don't have any question about this.
Yeah, but
Because
you
this is
know a lot.
our work together, so I would say.
Together. But apart from your in-depth situation, but this kind of case, the Vivek talked by him, and you can hear you may be able to be a third person's viewpoint. So therefore, how do you think? How do you feel about this works and this strategy of doing research doing? How do you think?
Yeah, I think the good point is, from two different countries, some communication is very important because, if you communicate with someone similar with you, they'll maybe always get the same
Yes.
answer for the same question, but sometimes there will be other mind from other countries' people, and so you can learn something from them. It's very important. And the working style is also sometimes different. So you can also learn something from them about this kind of thing. Yes.
Okay. Good. なんか、additional, just if it is so, the additional explanation, additional comment, suggestion, you have something?
Yeah. I think additional comment is like this, how to explain this? Just like because you cannot always working by yourself. It's not a good way. Just always because in here at PS, I found many students just working by themselves and not do the discussion. But currently, because I do a lot of discussion with Vibek and also Professor Zelinska together, and so we can find the problem immediately, but not. And also, different people will notice different things. Maybe I didn't notice it, but other people will notice it and point out. So it will like efficient working style. So I think this is good.
Good. Yes. So why discussion is necessary? Because you want to inform the other counterpart something that you will talk. And while considering and while talking, you may be able to find something, maybe something mistake, something good point, or something merit, or something. So talking or informing, it is not only for others, but also yourself, you may be able to reconsider and you refine about what it is, what this work is. You may be able to reconsider. So therefore, the discussion, communication to the others is very important. Not only self-learning, self-studying by himself, by itself, by yourself, but the explanation to others is very important. This is good enough work or something, and also the which part is necessary to do more, or what is the lacking part is you can find by preparation of talking or discussion, maybe. So therefore, some talks chance you should do, presentation chance you should always utilize it.
Yes.
Yes. Thank you for your good comments. はい、Vivek, じゃあ please なんか summarize finally, please do some comment.
Yeah, thank you very much. As I think Hishin made a very excellent point that we need, and also you made, we need a discussion from different point of view, like as you said, right? And that point of view not should be limited to one laboratory and one geographical locations, but also it has to be extended to other geographical locations. Like people have a different approach to solve a problem. The same problem, people has a different approach. So it is always good to well aware everybody's point of view so that we can contribute towards the right approach, not just wasting time. Because sometimes what happens that we are imitating in and limited our discussion to one area or to doing your own self, and we don't know where we are doing the mistakes. And we'll continue to do these things, and we will be actually consuming or wasting our time in terms of that. That means we will be unintentionally, I'm not saying intentionally, unintentionally. So a thorough discussion with the different experts and different pairs from different geographical locations always offer you or always allow you to find out exactly where you are doing the mistakes, so that you are in the next approach, you will not repeat the same mistakes, and we will not it will not cost you lots of time. So I think this is a very excellent points that Hishin raised. And also coming here, I'm also learning a different way of working culture, like which is different in Europe, right? And so I want to know that how it works here. So this is also offer me such platform through this collaboration is also offering me not only collaboration, as I said during my lecture, during my talk, that it's not about scientific research. It has to be considered as a different avenues in different way, like, you know, to learning the culture, learning the working culture, also learning that how we can collaborate, like in terms of research. That means what are the other avenues that how we can build a relationship, not only through scientific, emotionally, and also in a cultural way, so that we understand and we not get surprised or not get disappointed through that.
Okay. Thank you very much. Maji-kun, so therefore it's good to attending here. So therefore it's a very good chance to hear from the different viewpoint from the ordinary or current IPS professors' considerations. That is a very, very good chance. You may be able to understand about it. Dutta-san, you should add, could you add something to talk today? No? That's all for today?
That's all, Professor.
Okay. じゃあ、さあ、we will end this today's talk, today's session. なんか next time is maybe I will more asking to the participant, but because this is just the end of the Shunsetsu Spring New Year's Festival in China, so therefore there is no student in here, so therefore maybe the other student don't come here. So sorry about this situation. But
no, it's fine.
Thank you for talking today. And maybe the next time, more professors, more students will come. Yes.
Thank
Yeah, that's all for this time. Thank you for attending. See you next time. Thank you. See you.